Tony took 7/10 of an hour to finish his exercise. How many minutes did he take? To draw this as a bar model, I'm going to first start by drawing my whole bar and separating it into 10 parts so that I can show 7/10 of an hour. So I now have 10 parts. I know that I needed 10 parts because that's my denominator or my naming part. Now I want to illustrate 7/10. So to do that, I can just shade in these 7 parts here. This is going to show me the amount of time it took Tony to finish the exercise, and that's what we want to know. However, we don't want to know it in hours or as a fraction of an hour, which is what we're given. We want to know what it would be in minutes. So my whole, instead of it being 1 hour, is 60 minutes because I want to know how many minutes. Now to find out how many minutes it took him, I'm really finding 7/10 of, which we know means times, of an hour, and we're substituting in 60 minutes so that we convert this into minutes. So 7/10 of 60, when we solve, we can cross cancel here. They're 10 and 60 are both divisible by 10. So I have 7 times 6, which is 42. Cross out my question mark, and that would be 42 minutes. So Tony took 42 minutes to finish his exercise. Ashton bought 20 apples. He ate 5 of them. What fraction of the apples did he eat? What fraction of the apples did he have left? Now we might be able to take a look at this and just come up with the fraction, but we do want to illustrate it. So to illustrate this problem, I'm going to draw a full bar once again, and I'm going to break it up into 20 parts. And I'm breaking it up into 20 parts because I know that he bought 20 apples, so that's my whole amount. He ate 5 of them. So I'm shading in 5. This is what he ate. And he had the rest is what was left. So now I have to represent both as a fraction. So I know that I have 1, 2, 3, 4, 5 out of 20 here, which can be simplified to 1/4. So he ate 1/4. And he had 15 out of 20 left here, which can be simplified to 3/4. So he had 3/4 left. Emily bought 15 stamps. She gave 2/3 of them to Maggie. How many stamps did she have left? To illustrate this problem with a bar model, we're going to have to first draw our whole bar. This is again a part whole model. I know that Emily bought 15 stamps, so I'm going to label the whole bar 15. She gave 2/3 of them to Maggie. So since we're given this fraction, we know that the total number of parts is going to be 3 because that is our denominator. So I'm going to split it into 3 parts and label 2 of them Maggie. I'm labeling 2 Maggie because the fraction that she gave to Maggie was 2/3. How many stamps did she have left? Now I can label my question mark. So to solve this problem, I'm finding 1/3 of, which we know means times, 15. When I solve this, I can cross cancel, and I would get 5. Or you might have seen that you could solve this using the unit method. Using the unit method, you would see that we have 15 in all, and we needed to divide by 3 in order to find just 1 unit, which is 5. So she has 5 stamps left. Larry jogged 2 3/5 kilometers. How many kilometers and meters did he jog? So we're wanting to convert 2 3/5 kilometers into kilometers and meters. So what we're really finding is 2 3/5 kilometers equals blank kilometers and blank meters. Now, once again, I can illustrate this with a bar model. I know right away that I don't need to do anything with my 2 kilometers. They are already in kilometers, so I don't need to change anything. I can go ahead and write that over in my answer. But I do have to change 3/5 or convert 3/5 kilometers into meters. To show that, I can draw a bar. I will separate it into 5 parts because that's my denominator. 1, 2, 3, 4, 5. I know that we have 3/5 of a kilometer, so this is going to be my question mark. Now think about it. I want my answer to be in meters, not kilometers. So my whole amount, I'm not going to write 1 kilometer. I am not going to write that because that is just going to give me another fraction of a whole. What I do need to know, or what I do know that will help me, is that 1 kilometer is equal to 1,000 meters. Now that I know that, I can label my whole 1,000 meters because they're the same. And I want to convert it into meters. So this is really my conversion factor. So now I'm finding 3/5 of, which again we know means times, 1,000. Now when I solve this, I can cross cancel. 5 can be divided by 5. 1,000 can also be divided by 5. And then I multiply my numerators and my denominators. And I get 600. So I have 600 meters. So Larry jogged 2 kilometers, 600 meters.